Good day once again, friends. Here is a new day. I remain Mr. Jude Anadozie. We are through with everything on vectors, but vector products. So, in my last video, we dealt on scalar products. Today, I'm going to the last part of vectors, which is vector, vector, vector product. I will be slow in this. Why? Reason why I need to be slow is for you to understand every point I am making. Because the aim of this is for you to all to understand. And to my students, to my friends in India, thank you. Because I see I have more of Indian subscribers and those that view me this channel, followed by Ethiopia before Nigeria. I still have some from Germany, Great Britain, Spanish, all over the world. I appreciate you. Thank you. So let's move into business. The vector product of two vectors, vector A and B. The vector product of two vectors is also known as what? Cross product. It's also known as what? Cross product. That of scalar, as I watched the video, is known as dot product. That of scalar product is known as dot product. While vector product is known as what? Cross product. And as the name suggests, the vector product is itself a vector. The vector product is itself a what? Vector. The scalar product of two vectors is a scalar. The vector product of two vectors is a vector. Try to understand. You can go through my previous videos to understand better. And if you have any challenge on vector, start from the first video on vector. I believe before you get to this point, it will start making sense to you. So to define the vector product A cross B of two vectors, we again draw the two vectors with their tails at the same what? Point. Let's assume we have this vector B, then this is vector A, and the angle here is phi. I get it, man? Now the vector products will go this way to be perpendicular to this, also perpendicular to this. This is vector product of the cross product of A and B. So you see there's an arrow pointing towards this direction. I said the vector product of two vector is itself a vector. That's the direction. This obeys right hand rule. Now vector A towards vector B, the direction A towards B. So the vector product is pointing upwards. The direction is what? Upwards. If it is B moving to A, meaning to be like this, B towards A, the vector product will be what? Pointing what? Downward. What do I mean? And since if we have something like this, as I'm going to be slow, the aim is for you to what? Understand. This is B, and this is A. Now, if it is what the direction our phi is, so what does it mean? It means here we move down. Here it will be cross A, and B cross A. And B cross A relating it to this is equals to, because now you can see it will be okay. Is it covered? It should. Okay, let's proceed from here. So the two vectors, then they lie in the plane, as you can see. We define the vector product to be a vector quantity with a direction. It's a vector quantity with a direction perpendicular to the what? This plane. Let's assume this is on a plane. On a plane. Are you getting me? Just like this going up. Okay, something like this. This one is on a plane, like horizontal plane, while this one was vertical upwards. You can see what I'm doing. So these two on the plane are like these two. Then the vector of the, if these two are vectors, are you getting me? So the cross product of this vector is pointing upwards. It will move upwards, obeying what? The right hand rule. If it is this going towards here, it will move upwards using the right hand rule. Then if reverse is the case, this coming this way, it will point downwards. So that is for that for now. So that is for that for now. And I'm moving gradually. So if I take just as the way I treated the scalar, if I take two vectors like this is vector B, this is vector A. As you already know, the cross will point what? Straight. It's vertical. That is always vertical. Are you getting me? If these are on a plane, the cross which is vertical is same as this. If here is a phi, to get this vertical point is going to be what? Vector B sine phi. Here perpendicular. If you get it, here becomes our opposite. Here being our what? Hypotenuse. Sine theta, opposite, let me say y. Hypotenuse is vector B. So y is equal to what? Vector B sine theta. Vector B sine theta. That is how that goes. And where's my duster? Okay. I hope at this point you're still okay with this. And if I'm to work with this, let's say the vector product of vector A and vector B is this. Let's call this vector C. Vector C equals what? Vector A cross vector what? Vector B. So what does it mean? So now Bringing this into it, I cannot say C is equals to what? A, B, C, 5. So that is the magnitude of the vector, which is what? The vector product, the cross product of what? A and what? B. A and B. Now B is moving towards A. If it is A moving towards B, it's going to be B A sine alpha, sine phi. Sorry for that. So we measure the angle phi from here is from A to B. Here is from B to A. And take it to be what? The smaller of the two possible angles. What are possible angles? We have 90 degree, 90 degree, phi. Smaller of the two possible angles. So phi ranges from what? It ranges from 0 to 180. It becomes 0 when the two vectors are in the same direction, parallel in the same direction. And it becomes 180 when they are in opposite direction. This goes this way, this goes this way. This angle becomes what? 180 degree. But when they are in the same direction, the angle between them is what? 0 degree. So these are 5 is from 0 to 180. And take note, in first quadrant, all is positive, and in second quadrant, sign is positive. What does that mean? It means that vector product can never be what? Negative. Without even being told, you should know that vector product can never be what? Negative. Sine of any angle between 0 to 180 can never give you a negative value. The lowest you can have is what? 0. And the highest sin theta value you can have is what? 1. So let's proceed. If sine phi is greater than 1, is greater than 0, sorry. Okay, sine phi, okay, I say it's greater than 0, and it's never what? Negative. As must be the case for what? Vector what? Magnitude. And I've also said that when vector A and vector B are parallel or antiparallel, they are parallel or antiparallel, phi is equals to 0, as in this case, or 180. Are you getting me? And whenever phi is 0 or 180, C is magnitude of C is 0, because sine 0 will give you 0 and sine 180 is also 0. 0 multiplied by any magnitude will also give you what? 0. So what does it mean? That is vector product of two parallel or antiparallel vectors is always 0. Parallel or antiparallel is always 0. That is the vector product of okay, and in particular the vector product of any vector with itself is 0. That in terms of what? Parallel. Of any product with itself is what? 0. Recall in scalar, it's when it's 90 degree that has 0. But when it's not 90, it can be positive. When it's below 90, it's positive. And when it's above 90, it's negative. That is talking about scalar product. That the video before was this video. Okay, I think I should be moving ahead. Okay, so let's touch some important things here, making reference to my past video. So that means vector product versus what? Scalar vector product, scalar product. So be careful not to confuse the expression. Don't confuse this expression for the magnitude of vector products A cross B with the similar expression. This is what? This for the dot product, this for what? Cross product is A captured. Okay, it's captured. Okay, don't confuse the two, the similar expression. To see the contrast between these two expressions, imagine that we vary the angle between vector A and vector B while keeping their magnitude what? Constant. When vector A and vector B are parallel, the magnitude of the vector product will be what? 0. When they are what? Parallel. When they are parallel, what does it mean that they be parallel? It means the angle between them is what? 0. So when angle between them is 0, sine 0 is 0. And because sine 0 is 0, vector product will give you what? 0. But cos 0 is 1. So when scalar product, when they are parallel, that is where scalar product will be what? Maximum. That's where scalar product will give us what? Maximum. And when vector A and vector B are perpendicular. Perpendicular in what sense? On the plane, they are 90 degrees from each other. Okay. The magnitude of the vector product, this will be maximum. Why? Sine 90 is 1. Cos 90 is what? 0. So the scalar product will be 0 when it's perpendicular, but vector product will be maximum when what? Perpendicular. Is there anything I might have omitted? I've made mention of the direction in the right hand rule. If coiled this way, the other way. Is there any other thing I need to touch? I don't think so for now. I think so. I will bore you all with the class. Let's move to calculation. Calculating the vector product using what? Components. Calculating vector products using components. So still on what we have done so far. So if we know the components of vector A and vector B, we know the components of vector A and vector B, we can calculate the component of the vector product using a what? Procedure similar to that of what? The scalar product. First, we work out the multiplication table for the unit vectors. Unit vectors. All three of which are perpendicular. These three are what? Perpendicular to what? To each other. The vector product of any vector with itself, I've said that the vector product of any vector with itself is 0. The vector product of any vector with itself is 0. What does it mean? With itself, just imagine, okay, vector product to vector parallel is parallel to itself, the same direction. Are you getting me? Is 0. What does it mean? I mean that what I cross I is same as what J cross J, same as what K cross K is what 0. Take note of that. Take note of that. Take your time to what process it. Okay. And in the right hand rule, I said I let you know that I cross J will be same as what minus J cross I and same as what 1. 1 is same as 1. Taking it as 1. But looking at these are unity vectors. Looking at Pythagoras or whatsoever, I said it's always in the what vertically up. The vector of this on the same plane is same as this, right? And if this be our I and this be our what J, so and this becomes what the vector, the cross products. If this vector A, okay, A X I, A X J, and here's going to be what A okay, A Y A A K. So change is what vector K. What difference between here and here? What is not that here is minus 1, no. What is just changing that is vector we are doing here, not scalar. Assuming this was like this is our I, this is an assumption, and this is our what J. Let's take this to be this one. So this one is going to be what? This is your I, the same direction with this. You can see now the direction of J has what? Changed. Direction of J was changed. So when you cross these two, you are going to have what? A K. When we're this scalar, we are dealing with what? Magnitude. So I should say I dot I, 1 dot 1. But now we are dealing with vector. In vector, I pay more attention to what? So also what? Direction, not just the what? Magnitude. So what does it? So if this J cross K, J cross K, the same thing as what? Minus K cross what? J, which will give you what? I. And we have K hats plus cross I hats, theta minus I hats. Take note of this because they will come in handy in next section of what going into very soon. So now, what does this now mean? It means that vector A cross vector B is same as multiply by what? Bx. Hope we are on the same page. Hope we are on the same page. So, proceeding from here, first thing first, okay, I'm sure with this multiplying everyone here. Now over to this. And this. Okay, at this junction, what, okay, is it covered first? Okay, this. What do we observe? We're having I cross I here, and I cross I is 0. This gives us 0. J cross J is here, which gives us 0. K cross K is there, which is what? 0. Okay. Okay. So now I'm having IJ here, and here is what? JI. That means if I want this, okay, if an IJ I cross J is K, so let's start with I. So we'll go for what? JK. Okay, JK is here. So say AY, AYBZ, AYBZ, JK, right? JK. Another JK here again. Okay, this is KJ. Meaning if I should change this to JK, this is okay. Plus AZBY KJ. So what am I observing here? Okay, this is my I, which could be your X. Now I want to make it X, Y, Z. So X is for I, Y, Z, J, Z, K, I, J, K. This is for I. So for J, J is what? K, I. Where is K, I? There is it here. That is our K, I. So Ki, okay. This is Ki here. This is Ik. Okay, wait for Ki starting with this. This is Az Bx Ki. Ki. Then this is Ik plus Ax Bz Ik. Okay. Then now move to K. Okay. Axij Ax plus Ax By Ij. Now Ij again. This plus Ay Bx J cross I hope you are with me. Sorry, I have to erase. Okay, no problem. I'm moving up now. Let me erase here. Let me erase there. Now here we have AYBZ. This is JK. This is KJ. If I'm to swap this, K cross J is what? Minus J cross K. Right? J cross. Okay, this one is JK. So if, okay, I'm sure you understand what I mean. Just here, J is changing direction. So if I want to now make it JK, let me bring it down. If I now want to make, see here JK, I want to make it to be JK. What I need to do, if I change it to JK, what means that minus will come in here. Minus will come in here. If this is KI, so if I change this to KI instead of IK, and here it was minus IJ, the same thing. No, IJ, sorry. Here it was minus. Then captured, right? So now going a little bit up now. Okay, this is now is AY BZ. something in common. They had this JK in common minus AZ BY. What they have in common is what? JK. And JK is seen as what? I. Plus AZ BX. KI is common minus AX BZ KI. And KI is same as what? We need vector J. The next is AX BY minus AY BX IJ same as what? Unit vector K. Captured, okay. Not really. Okay. Okay, it's okay like this. So that is where we are now. That is where we are. So I think I'm done with this. Please can rewatch the video as many times as you can to have a perfect understanding of what is happening. We have to grow together. We have to grow together. So take your time, look at this and look at it well. It's something you can handle. So if vector C is vector product of vector A and vector B, so the component Cx will give us what? Will be this, which is what? AYBZ minus AZBY. You already know what the rest will be. Okay. And for those of us who already have knowledge of determinants, who already have knowledge of determinants. Look here, there's no x here. Here, there's no y there. Here, there's nothing here, z. So I can say the vector product can also be expressed in determinants as what? A cross B I J K. Y A Z B X this is nice. See? So this is how our formula came about. About that. The type that can be two vectors. That is just that for that. So I think that is everything on any kind of proving that you have on vector. So let's see an example and see how we can apply these formulas, and after that I think I'll be through with this topic, except you have a special question, then I'll bring me back to this topic. So let's see a scenario where we have when vector A has a magnitude of 6 units, have a magnitude of 6 units, and is in the direction of the x-axis, and is in the direction of what? X-axis. Vector B having a magnitude of 4 units. Vector B has magnitude of 4 units and lies in the xy plane. That means not in the x-axis, it's not directed x, it's not directed in the y, and not directed in the z. Just between x. Vector A is on the x-axis. If here is x-axis, vector A lies here. The 6 units. Vector A lies there on the x-axis, while vector B is in the xy plane. So here is 30 degree. Vector B 4 units. With the axis x-axis, okay, with in the xy plane, making an angle of 30 degree with the x-axis. Find the vector product. We should find the vector product, which is very, very what? Simple. You already know. I need any of your formula that you want to use. A cross B, same as what? A B sine 5. Our A is 4. No, our A is 6, sorry. Our B is 4. Sine 30. Sine 30 degrees. Sine 30 is 0.5. So this is 24 multiplied by 0.5, which should give what? 12 units. 12 units. Give it 12 units. But can we use the other scenario to solve it? Yes, we can use the other method we derived to also what? Solve it. What is that? I can say equals what? Remember this? This is J, right? Y, Z, Y, Z, X, B, X, Y. Okay. A, Y, B, X. So what's the K? Direction. Having done this, let's see if we are going to have same answer. Our AX A in the x-axis, in the x direction. Our AX in the x direction is 6. A is 6. What is AY? A vertical. A is directed at the x-axis. Again, it's B that is in the XY plane. That means A vertical of A is 0, and there is no Z, also 0. So BX, B to the horizontal, B is 4, 30 degree to the x-axis. So to get the horizontal component of this, remembering our component of vectors, is going to be what? 4 cos 30. 4 cos 30. Then BY, vertical component of this, is going to be what? 4 sin 30. Then the other one, BZ, there's no Z. 0. Let's see what our answer will be. We use this method to get this. Let's see how reliable this formula is. So let's go. This is the x, y, and z. So A cross B, AY is 0, multiplied by what? BZ. BZ is 0, minus AZ is 0, BY. BY is sin 30 is 0 0.5. 0 0.5 times 4 is 2. This for the x, plus AZ is 0, BX root 3. Root 3 over 2 minus AY. AY is 0. What am I doing? AZ, BX, AX, sorry, 6, BZ, BZ is 0, BZ is 0, plus, is it captured? Okay, okay, plus AX, okay, AX 6, BY is 2, minus, open bracket, AY is 0, BX root 3 over 2. No, this will give us 0. This also is 0. Everything here is 0. This is 0. This is 0. Everything here was 0. So A cross B is 12 minus 0. This is also 0. This gives us what? 12 units. Same as when we did what? AB sine theta. A is 4 times 6 sine 30. Remember? Which also gives us what? Proving that what the two formulas what are what perfect hand. Okay. At this point, say I'm through with vector, except to have any special stuff that will take me back to this. I so much appreciate your time for watching, going through this video. And please, anyone that still have any challenge, let me know. So from here now, I'm going towards a different topic. A student request I treat this vector. That is what made me to treat this topic. But if you think there's a topic you love us to look into, you can let me know in the comment section, and I promise you I will surely do that, and I will do justice to it. You are free to comment, ask me question on my in the comment section, and I will respond. Invite your friend to subscribe to the channel. You can see lots and lots of things are happening here. I'll give the best. I'll break down the formula to you, and I'll show you how what is being what gotten or what derived. I promise you I'll give you the best. Thank you, and I love you.